For decades, China has approached its rivers with significant ambition, transforming major waterways to support national development. The country's relationship with its rivers is closely connected to its history, culture, and long-term planning. From early irrigation systems to modern infrastructure, China has consistently viewed its rivers as both a challenge and an opportunity. This approach was exemplified by the construction of the Three Gorges Dam, which stands as a symbol of technological achievement and national progress. The dam, located on the Yangtze River, demonstrates China's capacity to modify its natural environment through engineering. The dam has helped control floods that previously affected millions, generated substantial electricity for urban and industrial use, and required the relocation of over 1 million people. These outcomes have led to ongoing discussions about the social and environmental impacts of such projects. These developments have prompted debate both within China and internationally. Critics have raised concerns about social and ecological effects, while supporters view the project as an important step for modernization and energy security. Despite differing opinions, the Three Gorges Dam has become a central part of China's energy strategy and has influenced the planning of future hydropower projects across the country. Attention is now focused on the Tibetan Plateau and the Yarlung Tsangpo River, where the proposed Yangtze hydropower project represents the next phase in China's dam-building efforts. This region, often referred to as the Water Tower of Asia, contains significant water resources. The Yangtze project is notable for its scale and for the technical and environmental challenges it presents. Engineers and workers are tasked with advancing development while considering the preservation of sensitive ecosystems. The Yangtze Dam is positioned as a component of China's transition to cleaner energy, supporting national and global climate objectives by providing renewable electricity and reducing carbon emissions. The Yangtze hydropower project reflects China's ongoing reliance on engineering solutions to address national needs and its approach to balancing progress with sustainability. The Yarlung Tsangpo, originating on the Tibetan Plateau, is a river of staggering altitude and spiritual significance. Its most dramatic feature, the Great Bend, plunges into the world's deepest canyon, creating unmatched hydraulic energy. This volatile region, shaped by colliding tectonic plates, is one of the most seismically active on Earth. The same forces that create its power potential also threaten any human construction. Strategically, the river becomes the Brahmaputra in India, making its control a matter of international consequence. By managing the headwaters, China gains leverage over the water security of its southern neighbors. The Yarlung Tsangpo is more than a river. It's a shared resource with profound geopolitical implications. Any intervention here reverberates far beyond China's borders. The Yangtze hydropower project redefines what we think is possible in the world of large-scale engineering and renewable energy. It doesn't just raise the bar for megadams, it completely transforms the concept, setting a new global standard for ambition and scale. Planned for the lower reaches of the Yarlung Tsangpo, the Yangtze Dam is designed to be one of the tallest and most powerful dams on Earth. With a projected capacity of up to 60 gigawatts, it would generate nearly 3 times the output of the iconic Three Gorges Dam, which itself was once considered the pinnacle of hydropower engineering. This single project could supply enough electricity to power tens of millions of homes and businesses, fueling China's rapidly growing cities and industries, and supporting the country's transition to cleaner energy sources. The dam will serve as the cornerstone of a vast new clean energy base in Tibet, transmitting renewable electricity thousands of kilometers to the energy-hungry eastern provinces, helping to balance regional development and reduce reliance on coal. But unlike the Three Gorges, the Yangtze project faces unprecedented engineering challenges. The site's extreme altitude, frequent seismic activity, and remote, rugged landscape demand innovative solutions and cutting-edge technology, pushing engineers to their limits. The Yangtze Dam is envisioned as the crowning achievement in a series of cascading dams along the river, aiming for comprehensive control and maximum harnessing of the river's immense energy potential. It represents a quantum leap in hydropower technology, pushing the boundaries of what's possible in both design and execution, and setting a precedent for future projects worldwide. The Yangtze Dam stands as the final, most ambitious piece in China's decades-long strategy to manage and utilize its great rivers. A bold vision that has shaped the nation's development and will influence the future of global hydropower. Chinese authorities proudly highlight the Yaxia Dam's extraordinary electricity output, projected to be so vast that it could rival or even surpass the total energy consumption of entire countries. This is not just a feat of engineering, but a symbol of national ambition and technological prowess. The dam is seen as a major leap forward for China's energy security, providing a stable and reliable source of power. By generating clean electricity on such a massive scale, it helps reduce the country's dependence on coal, which has long been a major source of pollution and greenhouse gas emissions. The integration of hydropower with wind and solar is also expected to create a more resilient and flexible energy grid. Central to China's climate pledges, the Yaxia project is a cornerstone of the nation's ambitious plan to achieve carbon neutrality by 2060. It demonstrates China's commitment to leading the global transition toward renewable energy and fulfilling its international climate obligations. Hydropower is celebrated for its ability to generate renewable energy with minimal emissions. The dam's turbines harness the natural force of flowing water, producing electricity without burning fossil fuels. This makes the Yaxia Dam a crucial weapon in the fight against climate change, offering a sustainable alternative to traditional power sources. Beyond energy, the construction phase brings significant economic benefits. It promises to stimulate the local economy in Tibet, creating thousands of jobs for engineers, laborers, and support staff. The influx of investment also drives the development of new infrastructure, from roads to housing and public services. The expansion of roads and power grids will help better connect the remote Tibetan plateau with the rest of China, improving access to markets, education, and healthcare. This integration is expected to boost regional development and raise living standards for local communities. On a broader scale, the dam could transform China into a regional energy powerhouse. By exporting surplus electricity to neighboring countries, China can strengthen its economic and political influence across Asia. The flow of clean energy across borders may help neighboring nations meet their own energy needs, while deepening economic ties and fostering regional cooperation. This cross-border power trade could be a catalyst for shared prosperity and stability. In official narratives, the Yaxia project is presented as a triple win for energy security, economic growth, and international diplomacy. It stands as a testament to China's vision for a greener, more interconnected future, promising benefits that extend far beyond its borders. Building the Yaxia Dam in the Great Bend means confronting unprecedented engineering risks. The site's seismic volatility makes dam failure a catastrophic possibility for millions downstream. Remote, high-altitude terrain complicates logistics, requiring new roads and tunnels through treacherous mountains. Construction will test the limits of human endurance and technology. Environmental hazards abound: landslides, reservoir-induced seismicity, and unpredictable geology. The dam's design must withstand both natural and human-triggered earthquakes. Every step pushes the boundaries of modern engineering, making this a high-stakes gamble. The Yarlung Tsangpo Great Bend is a biodiversity hotspot, home to countless unique species. Flooding the canyon for the dam would destroy habitats and disrupt fish migration, causing irreversible ecological loss. Local Tibetan and Monpa communities face displacement and cultural upheaval. Past dam projects in China have shown that relocation is often traumatic and difficult. Downstream, the Mekong's experience warns of erratic flows and lost fisheries due to upstream dams. The Yaxia project's secrecy and lack of transparent environmental review fuel mistrust at home and abroad. Environmentalists argue that such a transformative project demands far greater scrutiny and public debate. For India and Bangladesh, the Brahmaputra is a lifeline for agriculture and daily life. China's control of the headwaters raises fears of water shortages or sudden floods, making downstream nations vulnerable. Geopolitical tensions heighten these anxieties, as the dam is seen as a tool of leverage in border disputes. The dam could trap nutrient-rich silt, threatening the fertility of floodplains and millions of livelihoods. India's response plans for its own dams, risking a competitive race that could devastate the fragile Himalayan ecosystem. The situation underscores the urgent need for cooperation, but mistrust prevails. Without collaboration, the risks to people and environment multiply. China frames the Yaxia Dam as a triumph. Clean energy, economic growth, and global leadership. Official narratives highlight its role in poverty alleviation and technological advancement, downplaying risks. India and Bangladesh see it as a unilateral move threatening their water security and sovereignty. They call for transparency and treaties, but their concerns remain largely unaddressed. Local Tibetans face a mix of hope for development and fear of losing ancestral lands and traditions. Their voices are often drowned out by national ambitions and international disputes. Scientists and environmentalists warn of seismic dangers and irreversible ecological loss, urging caution and independent review. The debate is a clash of visions: progress versus preservation, national interest versus shared stewardship. The Yarlung Tsangpo mega dam embodies both the promise and peril of grand engineering. It could power a green future, but at immense environmental, social, and geopolitical cost. Building the world's largest dam in an earthquake zone is a gamble with global consequences. The lack of transparency and cooperation heightens the risk of conflict and ecological disaster. True progress demands a collaborative, basin-wide approach, balancing energy needs with ecosystem and community rights. The Yaxia project forces us to ask: are megadams the answer, or do we need a new vision for sustainable development? Its outcome will shape not just a river, but the future of how humanity manages nature's power.